So this is the AFM, or the atomic force microscope, and with this tool we're able to go in and bring a tip close to our surface and scan it around, and the deflection of the tip gives us a map of the surface at a very, very small scale. So one of the first things that we can do is load a tip or change a tip, and the way you do that is you undo these two little tabs here, so one on each side. You just pull this towards you, and on the other side as well, and that frees the head, and you unclip it, this guy. Make sure you squeeze the two tabs on the side to pull it off, and then we can slide this out, and it should just come out. Make sure not to drop it, and there we go. So this is the head of the AFM, and you can see that this guy right here is the tip. That little shiny piece is the piece of silicon that has the sharp cantilevered point on it. And if you ever need to change tips, you can simply set that down, grab a pair of tweezers, come in here underneath it, and sort of just pull up. And be careful, because this is magnetic, so it wants to snap down. You know, if you change tips and you bring in the other tip, I usually like to go slightly off center and bring it down slowly, and sort of, there's two little pins here, this guy, and they line up with sort of the big slot and this guy. So I usually come off slightly at an angle, that way it doesn't immediately snap into this hole. So if you do that, you can set it down and then sort of rotate gently into position and let go. And it's just magnetic, so it'll stay there. So we've put in a tip, and we need to reinstall the head into the unit. And we simply put it in the back here, align it with the rails, and slide it back, and then close the two tabs that we undid. So just push those away from you towards the back. So that's how you change that, and then we reattach this cable to the side here, and we're good to go. So then we need to turn on the AFM, and you do that down here. You click the big green power switch, and then we also need to turn on the power supply for the light, and we just click that there. This controls how bright it is. And then we should open up the software that controls both the camera and the AFM. So the AFM software is this guy over here that looks like a AFM tip. Click that. It's called XCP. And this guy is the camera software, and it just is the screen that we typically move to this second monitor over here. So then this, when it's running properly, it'll tell you it's connected here, and everything's in green. Sometimes it'll have an error and there'll be something displayed in red. You can typically close it down and restart it. That'll fix it. Or if it's telling you that it didn't detect anything, it's probably because you forgot to actually turn this on before opening up the software. So when this opens up, initially you'll get this curve. If it's set into non-contact mode, which is the primary mode that we use, you can also scan in contact mode, but you need a different tip, and some things are a little bit different. But with this, you set the resonance of the cantilever, and it's usually fine. So you can just click done. And next thing we should do is load up our sample. So if you're uncomfortable loading the sample because you're afraid of hitting the tip, you can load the sample before you reinstall the head unit. That way the tip is far away and you're not risking hitting it. Personally, I typically forget to do that, and we also don't change the head or the tip every time, so there's really no need as long as you feel comfortable sliding it in there, and there should be plenty of room to go ahead and just set that down there without, touching this guy up here. So we just set our sample on the stage. There's no vacuum in this one, so there's nothing to turn on to keep it down, but it's typically fine without. And then if you see here on this monitor, you can see that we now see our sample, and then this is the outline of the tip with the cantilever, and the sharp point is right here underneath the tip of the cantilever there. So let's find a region of our sample where we can see some sort of edge. The way you do that is by adjusting these two micrometers. They move the stage around, and I'm going to try to find the corner of our sample here so that we have some contrast. And there's two controls here that control the vertical. So the X and Y you do manually with those two micrometers, but the vertical is controlled through the software. And on the left here we have the stage control, and this controls the position of the head. So if we click down on this, it literally moves the entire head unit down as marked by this guy. And you always typically want to leave it slightly below this line in the middle. Never raise this up above this line because it messes up the software. So if you click anywhere below this line, it brings this down. As you can see, this is moving down, and if you click above it, it moves it up. And based on how far away you click from this line determines how fast it moves. So if you want to move very slowly and you click somewhere nearby, you can see that these numbers are changing, but this guy is moving very slowly. If you click further down, you'll see that it moves rather rapidly. So when you're far away and you're approaching, you can click further down to move it faster, but when you get close, you want to make sure you slow down so that you don't actually crash the tip into your sample. That'll break both the tip and typically your sample if it's something sensitive. The other control here is for the focus stage. So that only controls the camera independently of where the actual stage is. So we can do the same thing here. Clicking further down moves it faster, closer to the middle moves slower. And if we see here right now, we're not very focused on the tip. So if we click around, we can find the tip again and bring it into better focus. And that's pretty good there. So next we want to find the surface of our sample. And the way I like to do that personally is I like to first of all look at where the tip is and lower down sort of just by eye until we get sort of close, but not all that close. So we don't want to crash it accidentally. But you can see here we still have a gap that's visible, with our eyes between where the tip is and our sample. So that's fine. As long as you can see a gap, then you're still fairly far away. But once we start getting closer, we'll want to rely on the software to control it so that we don't crash it. So at this point, I typically look at this number on the focus stage and ignore this number. And what I like to do is go down until I find my surface just with the camera. And it should be around 400. And we can see that edge is coming into focus. And let's try to recenter this a little better so we can see some features. So as you can see right now, this image is scanning left to right. That's because the scan right here is on. If we click this off button on the scan, it'll stop so that we can see what's going on. And we can see that we're in fairly good focus on the surface at the moment, and the number here is a 412, for example. This number will always change, so don't remember a particular number, but just take note of where this number is for your particular sample, or for the particular location on your sample, because it can vary on the same sample depending on what your features are like. So we're at 412. We can go back up and refocus on our tip. And then you see we're at roughly 2000. We can then bring this down and watch this number and get it to roughly, like 600 maybe 550. And we know that we should be safe because we know that the surface is at roughly 400. So leave yourself some cushion so that you don't get too close and accidentally crash it. But we should be safe going to around 550. And at this point we see that our surface is starting to come into focus, and we see our tip, and at this point we can click approach here on the Z stage control. And once we click approach, what we'll see is that these numbers start decreasing by themselves. So at this point the software is controlling the position and slowly in increments stepping down and trying to find the surface based on the deflection of the laser. So that's the other thing to explain, is how this actually works. What it's doing is it's shooting a laser onto the top surface of this cantilever, and the laser bounces off and goes into a 4-quadrant photodiode, which is schematically shown here, is this guy. So there's a photodiode that's sectioned off into four chunks, and as the tip nears your surface, it'll deflect, and the beam will deflect into one of these 4 quadrants. And based on where the beam deflects, you can figure out your topography. So right now it's approaching, and once it finishes approaching, we'll set the laser to make sure it's centered on the photodiode. And that way we'll get nice resolution from our scans. And we should be getting that soon. If you're too far away from your surface when you click approach, it'll take a really long time, and eventually it might time out because it just never finds the surface and it thinks that something's wrong. Maybe the tip's missing or something like that. So you want to try to be fairly close to where you think your surface is before you approach. Otherwise you'll be approaching for a really long time. So now we see that we've found our surface. We're getting some signal here. Let me just decrease the scan size to 0 so that we're not scanning everywhere. If you click auto up here, what that'll do is it'll reset the scales so that you can see that you're in fact getting a signal. And there's 2 traces because one is the forward trace and one's the reverse trace. Ideally you want these to match up pretty well. In this case they're a little off of each other, but we haven't centered the laser, so let's do that and see if that fixes things. I typically like to do this not in contact with the sample. You should lift this up a little bit. So if I click 1 or 2 times on the up arrow here, we've gone slightly up off of our sample. That way when we're playing around with it, we're not accidentally damaging the sample. So then what we want to do is actually, if we trade places and you come around to the side, what we want to do is adjust these 2 numbers, the A minus B and the C minus D, so that they're as close to 0 as possible. That basically is doing A minus B is sort of this side, and C minus D I think is top and bottom. So we're trying to hit 0, and A plus B is basically our overall signal, and we want those to be as high as possible. So there's several different controls that control that. One is the laser position on the actual cantilever. So if we look at the head unit, there's 4 knobs, right? there's this one, and then these two little guys. So the two big ones control the actual laser position on the cantilever, and if we adjust them and look at the screen with the camera, we can see that the laser spot is moving when I do this relative to where the cantilever is. So this is moving it up and down. You want to be fairly near the tip with the laser spot, and sometimes if you can't find it, it'll just be off of the cantilever entirely. So you want to actually go all the way up until you're somewhere back here, and then move left to right to try to find it. Because if you're just off left to right and you're near the tip, then you won't see the spot at all. But in this case, it was pretty good to begin with, so let's just move it back down roughly to the tip. And that sort of determines this number, the A plus B number. You want this to be as high as possible. Above 1.2, really. If it's below 1.2, it'll typically not give you very good images, and you might have to restart or align your laser better. 1.45 is okay for now, but we can see that our laser, the red dot, is not centered, and these numbers are not very close to 0. So the next thing we want to do is adjust these two knobs, and that adjusts where the laser hits the photodiode. So let's do that and try to bring it into as close to 0 as we can here. Okay, so we can see we're at 0.1 and 0.1. That's sufficiently close for our purposes. Always go off of these numbers and not the image, just because the numbers are more accurate and what you actually care about. The image is sort of just a rough guide if you're somewhere far away. Okay, so also you'll note that up here this light is green. It basically shows the same thing here. If your laser is off in any direction, one of the red lights around the green light will line up to sort of indicate that you're off in that direction. But use the software, it's more accurate, gets you more precise. So now we're pretty close to our sample, but we're not in contact with it, so we can still move around without damaging the sample. So let's go over this edge here, where there's some kind of crack in this material, and then we can hit approach again, and this should only take a couple seconds since we only moved ever so slightly up away from our sample. And once it finds the surface, then we can actually perform a scan. And there we go. Now we have signal here. We still have our scan size set to 0, so this is sort of just the noise level. You know, there's people moving around the building, there's vibrations, it's picking those up, and they're roughly, so the unit here is 5 angstroms, so that's per division, it's 5 angstroms. And don't touch the, touching the screen moves this table, so it affects what the scan is doing, because the table is isolated. So you don't want to touch anything on the table during a scan, including the monitor, because as you saw, it'll induce errors. So right now our noise level is roughly 1 nanometer in amplitude. That's roughly what it is for this machine. So let us increase our scan size to something reasonable so that we can actually scan. If we do 100,000 angstroms, that's actually 10 microns, and we can see that now this starts scanning back and forth visibly. And let's adjust our scale bar here so that we can actually see what's going on by clicking auto. And That is a very weird profile. That shouldn't be what we see. You should see something that matches roughly what you're expecting. This weird discontinuity here is not what I'm expecting to see here. So let's disengage and try to move off slightly to a different spot. And approach again. And hopefully that goes away. This is an old machine, so sometimes it has bugs in the software or it has hardware glitches. Okay, this is a lot better. So we see that the two scans are roughly aligned to each other. Click auto. We see that the slope of this is diagonal, and we don't really want that. So the way to fix that is to go to slope here on the left and click auto. And you have to click auto many times actually to get it to readjust. So every time I'm clicking it, it's adjusting it a little bit. So you can sort of just click it a whole bunch of times and that'll usually level it off to a flat. If that doesn't work, you can also manually do it with the up and down arrows. Sometimes if you have some kind of topography there, it gets a little confused and it doesn't really know where flat is. So sometimes you'll have to do it by hand, but it's pretty straightforward to do that. So then the other important parameter is our scan rate. Typically it's 1 hertz, which means 1 line per second. If you want better resolution, you should decrease that and scan slower. That'll typically give you a better image. But that's about it, really. The way you get an image is you hit start on the scan here. Now we see that our scan has finished, and we probably want to save this image. And the way you do that actually is before you start imaging, you should set up your directory. So if you click this button here, it's create an open session, and clicking that brings up this window and lets you choose where you want to save this. So let's just unclick open previously used so that we can browse for a new location, and click the 3 dots here, and that'll open up the Explorer so that we can find where we want to put this. So let's go and put this in my folder, and let's just make a new folder and call it test. And then let's put in a session name, and we can just do like 1 and click OK. And what that'll do is it'll make a folder inside that. So if we go into users, my folder, we can see test and 1. So this directory here is where it'll save all the images. And what it'll name the images depends on what you've set in this setting here. So change preferences. Click that guy. That opens up this. You can change a bunch of things in here, but really the only thing that we really changed is the file name here, so the 3rd option. And this is the format it'll save in. So let's change this and say test 1 dash maybe. So now all the images will be named test 1, and then it'll increment the number after the dash. So the first image will be test 1, 0, 0, 1. And it'll just keep incrementing them. So you don't have to, once you hit apply and OK, then when you do subsequent scans, you won't have to keep adjusting the file name. As I was saying, now that our scan here has finished, one thing we might want to do is zoom in on a particular region of the scan if there's something of interest there. And the way you do that is by right-clicking on the image and hitting Send to Scan Area Control. And when you do that, it loads this image into the scan area tab. So if we click this tab, we see that, that's our image. And what this lets us do is it lets us change the size that we want to scan. For example, say we want to get more detail on a particular region, and it lets us also move this around. So let's just say we want to scan this edge and get a better idea of what's on the edge. Then we can just hit start and it'll scan that particular region of the image. You can also use it to offset, so you can move off of the image, to go scan the area immediately to either side or above and below. That also works. Just try to not offset a bunch. Don't do that repeatedly. And we can see that our scan is going. Our traces roughly match up, so that's good. That's also why we have two images. One is the forward trace, one's the reverse. And that is about it. The only other thing is that if you want to analyze any of these images, you can right-click them down here and hit Send to XEI. And that opens up the image in another piece of software that will let you obtain different information from the image. We can see some examples here. So this is the image analysis software that this AFM uses. And we have all these tabs across the top that let us do different things with the image. It even gives us a 3D map that we can rotate around and see sort of, it gives us the same information as the color map, but just in 3 dimensions. Sometimes it's easier to visualize things when they're actually 3D. But one thing that we often want to do is measure steps, measure the height of steps in our materials. And you do that from the line tab. And you select a line, you draw it across your step that you care about, and you can see the profile here. In this case, it's roughly 20 nanometers. And that's what I expected it to be, so that's good. If you want a slightly better idea, you can also right-click and hit Insert a Cursor Pair, and that will give you these readouts in this box. And as you move this around, it'll tell you what the difference is between these 2 points. If we delete those, we can also insert an averaging pair. So this inserts 2 cursors that have these bars around them, and you can adjust so that it averages over the area that's selected. So let's say we want a better idea. It's averaging getting your average height in the red region and then comparing it. You can also insert a line that is averaged in this direction, and you can adjust that in a similar fashion. And that is about it for how to use the AFM. So now we're done scanning, and our scan has finished. It is here, and it's shown up in our image folder as we expect it to. When you finish taking all the scans that you want, make sure you go in here and you fill out the logbook, the Excel log sheet, with the information that it asks, which is your name, the date, when you started and finished, the number of samples, and whether or not you did contact or non-contact mode. And if there's any issues, make sure you leave a note and notify the super user so that they can be addressed. And when you're done, you simply make sure to hit lift on the Z here so that you're not in contact with your sample. So click lift, you see that it starts moving it away, and make sure you stop it before it crosses halfway. So when it gets near that line, we will hit cancel. before it crosses the halfway point. And that gives us sufficient room to then pull out our sample and unload it. And at that point we're done, and we can just go here and switch off both of these. And in this case, I didn't close the software first, so it gives me an error. Usually you want to remember to close the software first, so it doesn't give you all these errors. But just click through all of them and it'll close anyway in a few seconds. Maybe. So yeah, I guess important point if you don't want to be stuck waiting is close the software before you power off, because otherwise it'll get stuck like this for a little bit until it closes out. But eventually it should close. There we go. And that's it.